Okay, so in this one we've got these three position vectors, and what we've got to do is we've got to find AC. Keep in mind AC is just going to be C minus A, so all I've got to do is write C as a vector and then subtract A, and that's going to give me AC. And that's the answer to number one. And then number two, it says the point M is the midpoint of AC. Well, kind of if you think about it, I've got 0, 0. I've got A up here and C up here and M somewhere in the middle. Remember, these are like points. All right, position vectors are just like their points because the other part of the point, the vector, is a 0, is the origin. Anyway, I can rewrite this like this, AM equals MC, because they have to since it's a midpoint. Well, then if I rewrite like I did just now, I can find out that M is going to equal C plus A divided by 2, or times 1/2. And so that's what I'm going to do. I'm going to take C and add A, and then I'm going to multiply the result by 1/2, and that's going to be the midpoint. So all I got to do is add these straight across, and then I'm going to multiply by 1/2, and I'm going to find out that M is the point 2, -1, 0, and the position vector is 2, -1, 0. So anyway, that takes care of part 2, except for they want it to be a unit vector. So a unit vector has got a length of 1. And this vector right here, well, we can figure it out. We use magnitude formula. So all we do is do the square root of 2 squared plus the square root of -1 squared plus 0 squared. I'm going to find out that this magnitude is square root of 5. So if I want it to be actually a 1, well, what I'm going to do is I'm going to divide each one of the elements by the magnitude. So it's going to be 2 over square root of 5, -1 over square root of 5, and I'm going to worry about 0 because 0 divided by square root of 5 is still 0. Now in part 3, they want me to find the dot product, which means I'm going to multiply these two. First, I've got to find out what AB is. So that's B minus A. And I've got them up above here, so all I've got to do is subtract them. Let's see, that's going to be -1, 3, 5, and I'm going to take away A, 1, -3, 2. So I'm going to find out that AB is going to be -2, 6, and 3. And I already know what AC is. We figured that out in the very beginning. To find the dot product, I'm going to line these guys up, and then I'm going to multiply. And remember, I'm going to get a number, not a vector out of this. So it's -2 times 2 plus 6 times 4 plus 3 times -4. That's all going to equal 8. Now to find the angle between two vectors, the formula is given on your formula sheet, but this is basically what we're about to do. So we need the magnitude of both AB and AC. So we find that equals 7, and then we find the other one. That magnitude is going to be the square root of 36, which is going to equal 6. And so now I've got all the pieces to my formula. All I've got to do is lay them out, and we'll go ahead and rewrite it so make sure you're with me. And then what's going to happen is I'm going to find that angle for cosine. So anyway, I fill in all the stuff I've got. I got to get cosine by itself. It's going to look like this. And then all I got to do to find the angle is do the inverse cosine of 8 over 42. And I'm going to find out the angle is 79 degrees. And that's all there is for that one. All right? Okay, and number 8, geometric progression. Second term is 12, and the sum to infinity is 54. Find the possible values of the first term. All right, so let's write down what we've got. First, we know that A2 is equal to 12, and we know the sum to infinity is equal to 54. We also know that, well, this is geometric, so if this is the first term, that's the second term. Well, I'm going to multiply the first term times r, so I can go backwards. The first term is actually going to be 12 divided by r, so there you go, I figured out the first term. And I know the formula for a sum to infinity is a over 1 minus r. So if I'm going to fill in the things I've got, I got the sum, I've got a, at least my version of it. And then all I've got to do is cross multiply here. And I'm going to get 54 minus 54r is equal to 12 over r. And then I got to get rid of this pesky r to the denominator, so I'm going to multiply everything times r. And I'm going to get 54r squared minus 54r plus or equal 12. And then I'm going to get everything on one side. And Then I'm going to either factor this. You could use your calculator if you got one of those white ones, or you can use the quadratic formula. Somehow what you've got to do is figure out what r is, and r is going to be, in this case, 2/3, or it also could be 1/3. And so then I find out that A1, because all I got to plug it back in, remember that's what they want to know is A1, that could be 18 or 36. Now, in part B, they say that the nth term of the progression is p plus qn, and s, the sum of n, is the sum of the first n terms. All right, so that seems kind of cryptic. We've got a sequence here. So let's kind of play this out. If this is my formula, well, the first term, well, that's going to be when n equals 1. So then I replace the n with a 1, so that's going to be p plus q. That's going to be the first term. And then if I want to find the second term, well, that's going to be a2, and then that's going to be q times 2, or 2q. The third term is going to be p plus 3 times q. Now, you'll notice if you want to lay this out like a sequence, p plus q is the first term, p plus 2q is the second term, p plus 3q is the third term. Well, all I'm doing is adding a q every time. So the d is equal to q. So I know a first term, and I know that q is equal to d. So I can plug in the formula. And here we go for our finding a sum. I'm going to plug in all the things I know. I know a is equal to p plus q, and I know d is equal to q, and that's all I got to do for part 1. And then in part 2 of B, what they want me to do here is, given that the sum of the first 4 terms is 40 and the sum of the first 6 terms is 72. And remember, this is this notation. That's all that means. S4 equal 40 means the sum of the first 4 terms is equal to 40. Anyway, I'm going to go ahead and fill in the formula that we just used down below. And I'm going to put in n is 4, and I'm going to put the sum at 40. And so it's going to look something like this. And of course, I can simplify it a little bit. And when I get done, I'm going to find out that these q's, I can add them together. That's going to be 2p plus 5q. And then I'm going to multiply those by 2. And I'm going to get 4p is equal to 40 minus 10q. And I'm sorry, 40 equals 4p plus 10q. And then I'm going to do the same thing on the other side with 72, only the n is going to be a 6. And so again, I'm going to simplify it. Just put everything in here. 5q, then I'm going to add the q's together. I'm going to get 7q, multiply everything by 3. 72 equals 6p plus 7, 21q. And now I've got these two equations. Well, I'm going to try to get p by itself. I'm going to divide everything by 4. P is going to equal 10 minus 2.5q. And now that I know what p is equal to, I can plug in where p is in the other one, 10 minus 2.5q. And then all I've got to do is simplify and get q by itself. And I'm going to find out that q, well, let's see, p12 is going to be equal to 6q, so q is going to equal 2. And then if I plug the 2 back in, I'm going to find out that p is equal to 5. And that's all there is for that one. And number 9, we've got a function f and g. Keep in mind this notation just means f of x is equal to 1/2 x minus 2 and g of x is equal to 4 plus x minus 1/2 x squared. And then this other part here, it says this intersection, and they say y equals f of x and y equals g of x. Well, that just means, hey, put some y's in place because we're going to graph them or we're going to make them equal to each other. So now all I got to do is take these. They both equal y, so I'm going to set them equal to each other. And then I'm going to find out what x is equal to. And I'm going to go ahead and multiply everything by 2 here to get rid of these 1/2. That'll make things a little bit easier, I think. Then all I'm going to do is get it to be a quadratic and move everything to one side. I'm going to get x squared minus x minus 12 is equal to 0. When I factor it, I'm going to find out that x is equal to 4 and x is equal to negative 3. And then when I plug those back in, I'm going to find out that y is equal to 0 and y is equal to negative 3.5. So that's good for part 1. And part 2, find the set of values for x, which f of x is greater than g of x. Well, notice I'm just I'm just filling in what they've told me. There's f of x, there's g of x, and I put a greater than sign. And you also notice it's exactly what we did. So it's going to end up being x squared minus x minus 12 is greater than 0. Well, this is a quadratic that opens up. And what we're trying to find out is where the x values cause the graph to be above 0. You can do a couple of different things. Visually, you can see it, I believe, but the x's have to be greater than 4 or less than negative 3. Or you can substitute a 0 in there. That's going to test the middle, and then we can find out that's not any good, so we know it has to be the outsides. Now, here's got a composite function for part 3. We want to take the g of x rule and put it into the f function. So anyway, that's going to look something like this. 1/2 times all of that, and then minus 2. And see, now all I got to do is a little algebra. I got to clean this up, simplify it, multiply, blah, blah, blah. I'm going to find out that I'm going to get 1/2 x minus 1/4 x squared. Now this is a quadratic, and I need to find out the range. And so the range, well, if it's got to open down because it's got a negative x squared, and so the range is going to be less than whatever the y value is of this vertex. So the easiest thing to do, I think, well, there's two different ways. You could find the derivative and then find the stationary point, or in this case, all you can do is find the vertex, negative b over 2a, and I think that's going to be easier, even though it's fractions. So negative b over 2a, that's going to be negative 1/2 over negative 2/4, and then that's going to be negative 1/2 over negative 1/2. That's going to be a 1. So x is going to equal 1, and then when I plug that back in there, I'm going to find out that y is going to equal 1/4. So the vertex is 1, 1/4, and that means that the range of this composite function is got to be less than or equal to 0.25. Now in part 4, it says find the smallest value of k for this function they've given us here. Now you know they've named it h, but it's the exact same function we had up here for g. So anyway, let's go ahead and take a look at this. It's got a restricted domain. The domain is going to be the x's are going to be greater than or equal to k. Now this quadratic opens down also, and I want to make it so the domain is restricted so it's a 1-to-1 function. And typically that's going to be at the vertex. So what I'm going to do once again is find the vertex here. And when I do negative b over 2a, I'm going to find out that this is x is equal to 1. Now, in this case, I really don't care about what y is, because the domain is going to be all of these values up into the 1. I'm okay with k equaling 1. Now, the thing is, if it goes below 1, well, then what's going to happen is I'm going to have this part as my y value. Well, that's not going to be a 1-to-1 function. It does not pass the horizontal line test. And so that's not going to result in an inverse. So I want to stick with the vertex and pick all the values that are bigger than that x. Okay? And then in number 10, we've got this curve y equals x to the third minus 2x squared plus 5x. We know it passes through the origin. And so they want to show the curve has got no stationary points. And so we're going to go ahead and find the derivative, and that's going to be 3x squared minus 4x plus 5. And if it's going to have a stationary point, well, then what we got to do is make the slope equal to 0, and I should be able to find out what x is equal to. But the fact that they're telling me there's no stationary points, I'm expecting not to be able to find out what x is equal to. So let's go ahead and use the quadratic formula. And when I do this, you're going to notice the discriminant is going to be negative. And if the discriminant is negative, then there's no real solution. So that's the reason why there's no stationary points. I can't solve this for x. I cannot find a stationary point for this. When the slope equals 0. All right, so that's the answer to part 1. In part 2, they want me, and this is confusing, to note the gradient of the curve by m. So that means I'm going to make the gradient of the curve equal to m. Well, this derivative we found over here, that is the gradient of the curve. That's how you find the gradient of the curve. Because remember, the slopes are going to be different depending on all the points. So I'm making that equal to m. Now what they want to do is they want me to find the stationary points of this new guy. And see, I get that this is kind of confusing, but we're going to find the derivative of this, which is simpler, and then we're going to make it equal to 0. And then we're going to find out that x is equal to 4 over 6, or 2/3. And so then when I plug in that 2/3 into the original, well, then what's going to happen is I'm going to find out what m is equal. And then I got to find out the nature. And so I'm going to find the second derivative. And all I've got to do is take a look at it. It's going to be 6. That's positive. So that's going to be a minimum value. Now 3 says show all the necessary working to find the area of the region enclosed by the curve, the x-axis, and the line equal x equals 6. Well, this is going to be a area underneath the curve here. So we're going to have to integrate. And keep in mind that when we're integrating, we're going to add to the exponents and then multiply by the reciprocal. Anyway, I get this, and then I'm going to simplify it a little bit. And then I'm going to use this as my integration function. And I'm going to put the two limits of 6 and 0 in there. So now I'm going to substitute it in. If I plug in a 6 for all these, I'm going to get a 270. And then when I plug in a 0 for all of these, well, I'm going to get a 0. And so the area is going to be 270 minus 0, or 270. And that's all for those. I hope that helped. And thanks for watching.